Hi everyone, this is Maths for Uni. This is question 1D from MAT 2019. If you find this video helpful, then please consider liking and subscribing. The question says, the area between the parabolas with equations y equals x squared plus 2ax plus a and y equals a minus x squared equals 9. The possible values of a are, in option A we have a equals 1, in option B we have a equals 3 or minus 3, in C we have a equals minus 3, in D we have a equals minus 1 or 1, and in E we have a equals 1 or 3. So for starters, let's have a think about how we could get this area between these parabolas. It's probably worth using integration to get this area because we're dealing with shapes that are described by general functions like parabolas in this case. In order to integrate, we're going to need to have some kind of limits. And so in this case, the limits will be the locations in x of the intersection points of these parabolas. So we take x squared plus 2ax plus a and set it equal to the other parabola a minus x squared. If we rearrange, this gives us 2x squared plus 2ax equals 0 because the a's cancel out. Then we can factorize this and we will get 2 lots of x times x plus a equals 0. And therefore the location of the points of intersection are x equals 0 and x equals minus a. So if we start to write down a formula for the area between these parabolas, then we're going to have the limits of minus a and 0. Now, in general, if we want to find the area between two equations, y equals f of x and y equals g of x, then we should subtract them and then integrate. And so here we take the difference of the two parabolas, which is x squared plus 2ax plus a minus a minus x squared, and then a dx inside our integrand. However, when we integrate, integration often gives us a negative number if our function goes underneath the x-axis. We're considering an area here as opposed to a signed area. So we want our answer to be positive no matter what. In order to achieve this, we can put down modulus signs both inside the integral here and also outside the integral here as well. Because even putting modulus signs inside the integral, if our limits are the wrong way around, for example, if a is negative, then we would get a negative area. So putting down these modulus signs will ensure that we get certainly a positive area and indeed the right area. So this is going to be the expression for our area between the parabolas, and so now we can simplify. We have the modulus of the integral between minus a and 0, and then another modulus, and then this subtraction here of the two functions. We've essentially done this before in calculating the points of intersection. It's going to be 2x squared and then plus 2ax. And then we have our dx and we have our finishing modulus sign. Now, in order to perform the integration here, we're going to need to be careful with this modulus sign that's on the inside of the integral. Because the integral is only on one side or the other of the y-axis, i.e. it goes between 0 and some value minus a that could be on either side of the y-axis, we can actually keep this modular sign after doing the normal integration that we would do. Namely, we get modular sign outside, but we get these square brackets, minus a and 0, and then the modulus of the normal thing that we would integrate. Namely, we get 2x cubed over 3 plus ax squared. Again, if this feels slightly unfamiliar dealing with these modular signs, then consider graphing out these functions over these intervals, and in particular our interval is considered to be the difference in points between the points of intersection, and therefore that's why we're allowed to do this with this modular sign. Now if we put in the values of x, we're going to get modulus sign of, then we have our minus from the minus a value, modulus of 2 minus a cubed over 3 plus a minus a squared. This gives us, in the end, the modulus of a cubed over 3. We've been given that this area is equal to 9, and therefore we set these two things equal like this. We can bring the 3 that's dividing the a cubed outside because it's a positive number, and so we get modulus of a cubed is equal to 27. If we ignored the modular sign, this would give us a equals 3. However, because the modular sign is there, a equals minus 3 is also a solution. As a result, the answer is B. If you found this content helpful, then please consider liking and subscribing. Thanks for watching, and goodbye for now.